Today's lesson is 2.6, multiplying and dividing properties for proofs. Let's take a look at the theorems that we have. In our first box here, we have two trisecting pieces. So BD and BE trisect angle ABC. So that means that this angle, and this angle are all congruent. RP and RY trisect QRT, so 4, 5, and 6 are all congruent. And you knew that 1 and 4 were congruent. So then guess what? Whoa! 1, 2, 3, 4, 5, and 6 are all congruent. So you can use this multiplication property, like multiples, to tell you what pieces you want, or you could even get bigger pieces like ABC to QRT, or ABE to QRY, TRP to CBD. Whatever pieces you want, you can use like multiples to get to that reason. So this is what it looks like to use like multiples. This would be the reason. Reason 1, you could get away with like multiples. All right, that means you have either two trisecting pieces in a congruent piece, or we'll shortly learn that you could have two bisecting pieces in a congruent piece, giving you the same reason. And then your end result is obviously bigger. So you can get away with using from yesterday the addition property multiple times, but a shorter proof would be using like multiples, because you want to multiply to get the bigger pieces instead of using addition a number of times. So in the next example, we say it's true for segments 2. So B was bisected here, Y was bisecting here, and then AB was congruent to QY. So that means all four pieces are congruent. We can get AC congruent to TQ by using the idea of like multiples for what it looks like. So that's what I want you to use. I want you to use the like multiples when you have two bisecting pieces. That's the hint. When you know you have two bisecting pieces or two trisecting pieces, that's when you want to use like multiples, or the next theorem, which is like divisions. So in this case, we got VQ bisecting MVP, and we got um, causing these two to be congruent, and we got REM being bisected by ET, which is these two being congruent, and then MVP, the very big angle here, is congruent to the very big angle here, and we want something smaller. So since the big angle are congruent, and you know that they're both being bisected, all the smaller pieces are congruent, and you could get the pieces that you want. So 1 could be to 3, 1 could be to 4, 2 could be to 3, 2 could be to 4, no matter what we are looking at. And that's going to be your like divisions here. So highlight this one. There's your like divisions that you want to use for that reason, like divisions. Once again, that's the idea that you had the big pieces, and then you are getting to the smaller pieces that you want. So that's like divisions versus the bigger one where you wanted an end result that was bigger. All right. And will it work for segments just like angles? Sure does. This time I said trisecting, so these three pieces, the big ones were congruent, so that means you could break all the smaller ones into pieces, and once again, it's like divisions. Okay, so let's look at the proofs that we have here. We have BE bisecting angle 7. BE bisecting angle 7, so that means that angles uh, 2 and 3 are congruent. We got FC bisecting angle 8, which is 5 and 4 congruent, and we already know that 1 and 6 are congruent. Well, we can get the big angles. We can get angles 7 and 8 congruent if we look at it, because what do we know about 1 and 2? 1 and 2 are adjacent, and they're forming the straight angle, so these are supplement. 6 and 8 are adjacent and making that straight angle, so these are supplement, which means that from 2.4 we know the supplements of congruent angles are congruent, so 7 and 8 are congruent. And then instead of using these as bisectors, because I told you, when you are given two bisecting pieces, think like multiples or like divisions. Don't use them as bisectors, okay? When you are given two, that's your hint to use this theorem. So you should write that down and remember it. All right? So, and then 1 and 6 were congruent. So then what's left over, we could get 2 or 5 or 2 and 4, 3 and 5, 3 and 4, whatever ones you want. So let's make the 7 and 8 congruent first. So what do we know? We know that angles 1 and angle 7 are adjacent. And we know that angle ABF is a straight angle. That gives us reason 1, angle 1 and angle 7 are supplement. We also know that angles 8 and angle 6 are adjacent and still forming ABF, which is a straight angle. Same reason as above. We have angle 6 and angle 8 are supplement. And we knew from our given information that 1 and 6 were congruent. These pieces together, up to reason 2, we know that angle 7 is congruent to angle 8. Okay, 7 used our bisecting pieces. But if 7 and 8, the big angles are congruent, we can divide it into smaller pieces because we know they're both being bisected. So now BE bisects angle 7 and FC bisecting angle 8. Those three things together, it's either going to be like multiples or like division. So let's see. We wanted angles 2 and 5. So those are definitely smaller than 7 and 8. So it's like divisions. So what is our reasons? Reason 1 was if two adjacent angles form straight angle, then supplementary. Hopefully you got that one. Reason 2 was the supplements of what? If congruent angles are congruent. So we got the subs of congruent angles are congruent. And the third reason right here looks like above, like divisions. Okay, I know that was challenging. There was a lot going on there. Okay, so let's look at the next example and hopefully it sinks in a little bit more. So we got AB is congruent to ED. This piece is congruent to here. Q is the midpoint. R is the midpoint. Well, a midpoint is just like a bisector. It's causing two smaller pieces to be congruent. So we got two of them. So because we have two of them, we have to either think like multiples or like divisions. And finally, we know that QC is congruent to QR. So all four of these pieces are congruent. We want AC congruent to EC. Well, if we can get these congruent from our like multiples, then we can actually add AB to it and ED to this side, and we have our big pieces that we need. So let's start with our like multiple. So we got Q is the midpoint of BC. We got R is the midpoint of DC. Okay. And we got CQ congruent to CR. Those three pieces together, and what are we getting? We want something bigger. We want BC and CD. So because we want something bigger, that means we're going to be using our like multiples. Now that we know that this piece and this piece are congruent, let's use our last given right here, that AB is congruent to ED. Underline it because it's given. These two added together from yesterday's work, we can say AC is congruent to EC. So we can actually use like multiples and addition in the same reason. So what do we have? Reason 1 is like multiples because we got bigger, like multiples. Reason 2, we added to get something bigger, so this is the addition that we have. right? That's the end of the lesson. But don't forget, in the given information, if you either have two bisecting pieces, two trisecting pieces, or two midpoint pieces, that's when you have to think, you know what, I'm going to be using like multiples or like divisions in that proof. If you get that and understand it, that's the only time you will use these reasons. Otherwise, don't worry about them. So when you have two bisecting, two trisecting, or two midpoint pieces, that's when you want to use like multiples or like divisions. Have a great day.